Good day, students. Let's do this quadratic graph. Given y equals x squared minus 8x plus 5. A. Make a table of values of the equation for values of x from minus 1 to plus 10. B. Using a scale of 1 centimeter to represent 1 unit on the x-axis and 2 centimeter to represent 5 units on y-axis. Draw the graph of the relation. Then C. From your graph, find 1. The minimum value of y equals x squared minus 8x plus 5. 2. The root of the equation x squared minus 8x plus 5 equals 0. Then 3. The line of symmetry of the equation x squared minus 8x plus 5 equals 0. So let's start again from the beginning. So given y equals x squared minus 8x plus 5. Make a table of values of the equation for values of x from minus 1 to plus 10. So I'm going to draw the table of values from x and y. For minus 1, the value for x is from minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I'll be looking for the corresponding value for y. So you are going to be substituting. When x is minus 1, substitute into this equation. That is minus 1 squared minus 8 times minus 1, then plus 5. So minus 1 squared is what? 1 times minus 1 give us plus 1. Minus 8 times minus 1. Minus times minus is plus 8 times 1 is 8 plus 5. 1 plus 8 is 9. 9 plus 4 is 14. So when x is what? Minus 1. Y is what? 14. Then when x is 0, what will be the value for y? You substitute into the equation. So when you substitute x squared, 0 squared minus 8 times 0 plus 5. So 0 squared is 0 minus 8 times 0 is 0 plus 5. So that means 0 minus 0 plus 5 give us 5. When x is 0, y is what? 5. When x is 1, so you substitute into the equation. When you substitute, so 1 squared minus 8 times 1 plus 5. 1 squared is 1 times 1 is 1. 8 times 1 is give us minus 8 plus 5. 1 minus 7, 8 is minus 7. Minus 7 plus 5 will give us minus 2. When x is 1, y is minus 2. So I believe you should be able to continue the procedure. So to get the other values of y. So when x is 2, y will give you minus 7. Then when x is 3, y will give you minus 10. When x is 4, y will give you minus 11. When x is 5, y will give you minus 10. When x is 6, y will give you minus 7. When x is 7, y will give you minus 2. When x is 8, y will give you 5. When x is 9, y will give you 14. And when x is 10, y will give you 25. So this is the table for the relation y equals x squared minus 8x plus 5. So to the second part of the question, saying using a scale of 1 centimeter to 1 unit on the x-axis and 2 centimeter to 5 units on the y-axis, draw the graph of the relation. So now this is my graph. So this is a graph I'm going to use today. Now if you look at this graph, you realize that what between between one thick line and the other thick line, I'm having 10 lines. So this is a graph for 2 centimeter by 2 centimeter. This is a graph for 2 centimeter by 2 centimeter, because from one thick line to the other line, I'm having 10 lines. So this is a graph for 2 centimeter by 2 centimeter. But in this question, the question says about using a scale of 1 centimeter to represent 1 unit on the x-axis. So this is my x-axis and this is my y-axis. So I need to coin 1 centimeter here because this is 2 centimeter by 2 centimeter, and for me to get 1 centimeter after this line, I will count 5 lines. 1, 2, 3, 4, 5. So I'm going to write 1 for this one, or the next thick line below 2, 1, 2, 3, 4, 5. So this is 3, this is 4, 1, 2, 3, 4, 5. 5. This thick line will be 6. So this is how to make 1 centimeter out of this. So because this is a graph of 2 centimeter by 2 centimeter, so you need to be counting 5 lines to be getting 1 centimeter. So after this, I'm having 1, 2, 3, 4, 5. So this is 7, 8. So 1, 2, 3, 4, 5, 9, 10. 1, 2, 3, 4, 5, 11, 12. So this is the positive axis. So this side is the negative axis. So let me also do this side. 1, 2, 3, 4, 5. This one will give me -1, -2. 1, 2, 3, 4, 5. -3, -4. So that's the scale of 1 centimeter to 1 unit on the x-axis. Then it now say and 2 centimeter to 5 units on the y-axis. So this is already a 2 centimeter graph. So 2 centimeter to 5 units. So I'm having what? The next thick line is what? 5. We're having what? 10. This one is what? 15. This is 20. This is 25. This is 30. So down here also, I'm having the negative axis, -5, -10, -15, -20. So this is the graph. So now I'm now going to plot the graph. And you need to note something here. Now on this graph, on the x-axis, on the y-axis, I'm having 2 centimeter is representing 5 units. So in 2 centimeter here, I'm having 10 lines. So I want to know the value of 1 line. So 10 line, if 10 lines is equal to 5 units, so what will be the value for 1 line? So you now see this 1 over this 10 times 5. So we should give you what? 5 here, 5 here, 2, 1 over 2, same thing as 0.5. So that means each line here is for 0.5. So I'm going to now plot the graph. When x is -1, y is 14. So when x is -1 on this line, y is 14. So if I'm to get 14, you realize that if this is 10, since on the vertical axis, each line is for 0.5. So 10 plus 0.5 is 10.5, 11, 11.5, 12, 12.5, 13, 13.5, 14. So 14 will fall on this line. And so I will now look at their point of intersection of this -1 and 14. So this -1, so this is the line of -1 and 14. So both of them are going to meet here. So I will mark that point for -1 and 14. So when x is 0 on this or at the middle here, then y is 5. So the line of 0 and 5, they will meet at this point. So when x is 1, y is -2. When x is +1, y is -2. So I'm going to have when x is +1 here, y is -2. So this 1 on x -2. So if this is 0, this -0.5, the next line, -1, -1.5, -2 on this line. So I'll trace it to where x is what? 1. So where the two lines meet at this point, I'm going to mark. When x is what? 2. When x is 2, y is minus 7. X is 2 on this line, y is minus 7. So minus 7, if this is minus 5, so the next line is minus 5.5, 6, 6.5, 7. So at this point where it now touches, it means with the line of these two. So it's here. So I'm going to mark that point. When x is 3, y is minus 10. So this is the line for 3 and this is minus 10. Both of them are meeting at this point. So I'll mark it. When x is 4, y is minus 11. So I need to get minus 11 at this point. So after this 10.5, 11. So I'll trace it to where x is 4. So both of the lines will meet at this point. So you mark it. When x is 5 here, y is minus 10. So minus 10 is on this line and this is 5. So you trace it to each other. So I'm going to mark this point. When x is 6, y is minus 7. So this is 6 on x, y is minus 7. So this is minus 5, minus 5.5, 6, 6.57 on this line. So I'm going to make sure it falls. So when x is 6, y is minus 7. When x is 7, y is minus 2. This is 0 this is 7 on x, y is minus 2. So 0.51, 1.52. So you trace it. So it's going to be here. Then when x is 8, y is 5. This is 8 on x, y is 5 here. So the two are meeting at this point. You mark it. Then when x is 9, y is 14. So this is 9 on x, y is 14. So if this is 10, 10.5, 11, 12, 11.5, 12, 12.5, 13, 13.5, 14. You trace it to where you have. So it's going to meet it at this one. It's going to meet it at this point. So you are going to mark it. Then when x is 10, y is 25. So this is 10 on x, this is line for 10, this is line for 25. Both of them are meeting at this point. So after plotting the points, so you now join it together. So you always target the next point so that you know how to bend your curve. So always target the next point. So I've been able to do that. You always target the next point. So now, then let's move on with the question. They now said that from your graph, find the minimum value for y equals x squared minus 8x plus 5. So the minimum value, you look at the peak point here, where you now trace the peak point here to your y axis. When you trace it to y axis, this one is going to be here, abi. So since each line is 0.5, this is minus 10, minus 10.5, this point is what? Minus 10, minus 11. So the y minimum will now be equal to what? Minus 11. So that's the minimum value for y. Then we are told to look for the roots of the equation. X squared minus 8x plus 5 is equal to 0. To look for the root of the equation, you are going to look at where this curve cuts the x-axis. It cut the x-axis at this point and it cut it at this point. So you are now going to read the values there. You know, for the x-axis, we are using 1 centimeter to represent 1 unit. So what will be the value for one line then? We want to know the value for one line on the x-axis. So in 1 centimeter, you're having 5 lines. If you're having 5 lines, is equal to 1 unit. So what will be the value of one line? That means I say this one over this 5 times 1, which will give you 1 over 5. 1 over 5 is same thing as well, 0.2. So that means on the x-axis, each of the line is 0.2. So if this place is what, 7, then this is 7.2. This place where it got the axis will not be 7.4. So that normal form. So the value for x there is so 7.4, or you are going to have two values. This side also, this is 1. So if this is 0 plus the next line was 0.2, 0.4, 0.6. So or 0.6 will be the roots of the equation. Then they now tell us the line of the line of symmetry of the equation. So when you talk of the line of symmetry, the line that will divide the graph into two equal halves, you are going to find it at the peak point here, minimum value here, the straight line that will divide it into two equal halves. So that will be, so you trace it to the value of this x, so that is x is equal to 4. So the value for the equation that of the line, the equation of the line of symmetry here will now be what? X is equal to 4. X equals 4. So for the work practice, you are going to do this. For the work practice, you are going to do this. Then A, copy and complete the table below, giving values for the relation y equals 3x squared minus 5x plus 3. So you have been given the table, you have to use, so you have been given some of the values, so then you calculate the remaining one. Then B, draw a graph of the relation using scales of 2 cm to 1 unit on the x-axis and 2 cm to 5 units on the y-axis. Then C, from your graph, 1, what is the maximum value for 3x squared minus 5x plus 3? 2, find the values of x when y is equal to 5. Then 3, what are the roots of the equation? So please ensure you like, subscribe and comment on this video. Thank you.